So we will start after a couple of minutes, maybe some participants will join. And the instructions will remain the same. In case of any doubts and queries regarding a particular problem, sufficient time will be given after a particular problem is solved. You can type in your doubts in the chat box. In case you are not able to type in your doubts and you are not able to explain your doubts properly in the chat box, you can use your mics. And kindly keep your mic. So it's 3 p.m. already. I think we can start. So let me just share my screen. So before we start, we are bound to give this introduction every time. So this is the live session 10 of the course Digital Circuits that is taught by Professor Santanu Chattopadhyay of IIT Kharagpur. Myself, Musab Rafiq, I'm a PhD student at the Department of Electrical Engineering here at IIT Kanpur. So in this session, we'll be mostly dealing with the problems related to week 10 tutorial. I think this will mostly cover your problem portions of VHDLs. And in the next 2 weeks, that is week 11 and week 12, we'll be mostly dealing with the problems related to microprocessors, more precisely 8085. So without further ado, I think we can start with the problem 1. So since some people joined late, I'll just repeat some of the instructions. In case of any queries or doubts regarding a particular problem, you can type it in your chat box. Sufficient time will be given after every problem is solved. In case you are not able to type in your doubts in the chat box, you have some problems, you are not able to explain your doubts properly, you can use your mic. And also new participants will be added only after a particular problem is solved. So I see some participants have joined. Let me just admit them first. Then we can proceed to question number 1. So let's start with the question number 1. So this question number 1 is a true and false. True is a multiple choice question. It states that which of the following which of the following statement is true? HDLs. HDLs here stands for Hardware Description Language. So we are giving the 4 options. Among these 4 options, only one is true. So number 1 option is hardware. HDLs and computer programming languages are similar. Hardware HDLs describe hardware rather than executing a program on a computer. HDL describes software and not hardware. And the last option is computer programming language describes the hardware. So this is a theoretical question, and you guys must be knowing after covering your 9 tutorial. So the correct answer to this question is option B. Hardware description language (HDLs) are used to describe hardware rather than executing a program on a computer. Hardware description language is basically a specialized computer language used to describe the structure and behavior of electronic circuits, and most commonly digital circuits. So question part B is your answer. So this was a theoretical question. I think There are no doubts regarding this. I think we can proceed to question number 2. So the question number 2 here states is another theoretical question. It states that which of the following is the basic building block of a design? A. Architecture, B. Entity, C. Process, and D. Package. Let me just read my question. Which of the following is the basic building block of a design? A. Architecture, B. Entity, C. Process, D. Package. So the correct answer to this is B. Entity. Entity is the basic building block of a design. All the VHDL designs are implemented by entity. We can imagine an entity as a black box with input. We have some input ports and we have some output ports. So since it is a basic building block of a design, I have here an example of an VHDL code for syntax for an entity. This is just the basic syntax to get an idea of what this entity is. So the entity syntax, so someone has joined, let me just admit them first, then he or she can also attend this. Yeah, Thalapasai, Verilog is HDL language. Yeah, we have these Verilog and VHDL. These are the two common most common HDL languages. Yeah, you are right. Here we are mostly discussing VHDL, very high speed integrated hardware description, integrated circuit hardware description language. So you are right. Verilog is also a HDL language. So let me just continue with this entity thing. So here we have this basic syntax of this entity. So as I said, this entity is a black box, which we can imagine as a black box with input and output ports. So the entity syntax is keyword entity. So here you must be seeing some of the parameters, some of the keywords are highlighted in blue. These are termed as keywords. So this entity is a keyword for this entity block, followed by the entity name. This is my user defined name, and then another keyword is, and then we have this port, followed by the parenthesis. Inside the parenthesis, we describe our inputs and we describe our outputs. So this thing, let me just this thing, input 1, input port 2. This thing are my inputs, two inputs. And how do I know these are inputs? Because of this statement in and in. And this is a std underscore logic, which means they are a single bit input, single bit symbol. And each of the line is ended with a semicolon. And then these two are my output ports. How do I know it? Using this keyword, followed by this std underscore logic as we saw in the input, and then the parenthesis is closed and we have the semicolon at the end. So in the port declaration, that was this port declaration, there are port names like in underscore port 1, underscore port 2, out underscore port 1 and out underscore port 2, followed by the semicolon, here colon, I'm just stating the rules, followed by the colon, then port direction. So this is direction, whether it's an input or an output port, followed by port type, and then the semicolons. The entity declaration will terminate. So this entity declaration will terminate by the keyword end, followed by the entity name that we defined here, and then the semicolon. So this was a basic thing about this entity, as we had this question here which asked us to which of the following is the basic building block of a design. So which was the correct answer to this was option B, entity. Now moving forward to the next question, that is question number 3 of today's live session, which is Intel 8086 is a dash processor. So we are asked to give the correct answer to this question. What type of processor, what bit processor is Intel 8086? So it's a theoretical question. Intel 8086 is a 16-bit processor. Now moving forward to next question, another theoretical question. It says that which of the following is not an EDA tool? So we are required to find among the options, we are required to find the answer which is not an EDA tool. So we have an option A, Verilog HDL, as someone was saying this in JATBox. It's a hardware description language, Verilog. We have VHDL, which is a hardware description language. Then we have Xilinx ISC, and option D, Visual C++. So the answer to this question is Visual C++. Visual C++ is a compiler for C and C++ languages. It's not a EDA tool. And Xilinx ISC is a discontinuous software tool from the company Xilinx. It was used for synthesis and analysis of HDL design. So all of these three are EDA tools, and this right here is not an EDA tool. This is a compiler. Let me just type it clearly. Visual C++ is a Visual C++ is a compiler for C and C++ languages. So if there are any doubts, please type in. Huh? Electron design automation. 16-bit processor means the computation occurs in a 16-bit word. So see, you have computation only occurs in 16-bit in a single instruction. So electron design automation, EDA. And Vimala has asked a question, what is meant by 16-bit processor? So your computations occur in 16-bit words. So address. So yeah, can you please repeat what you are asking? Yeah, obviously. Yeah, that's true. Your registers and all, they will all be in 16 bits. Computation will only occur in 16 bits. Right now, your processor, if you can have a look at your desktop or your PCs and laptops, they are either 32-bit or 62-bit, 64-bit, sorry. In the early generation, microprocessors like in 80s, 1980s and early 90s, they were 8-bit or 16 bits. I think 8085 was 8-bit, if I'm not mistaken. 8085 was 8-bit. And Vimala EDA is full form is Electron Design Automation. I hope you got that. Yeah, can we? It's a just the way like how we design the circuits and all in for hardware description tools. Like we have Verilog, we have VHDLs. So if we can move to the next question, that is question number 5. Yes, question number 5. Question number 5. So the question number 5 asks us is another multiple choice question. It asks us what logic synthesis process is of A. Converting behavioral level description to structural level netlist. B. Converting structural level netlist to behavioral level description. C. Converting high level language to machine level language. Option D. Converting behavioral level description to architecture level. In another theoretical question, the correct answer is option B. Option A. Converting behavioral level description to structural level netlist. In easier terms, we can say that converting an RTL to design in terms of logic gates by synthesis tool. So it's a pretty much straightforward theoretical question. You can refer to your V10 lectures to get a better idea of it. Then we have this another question: which of the following is the default type of ports of an entity? A. Variables. B. Constants. C. Signals. and D functions. So entity, as we just saw it, is that we consider it as a black box which consists of ports, inputs and outputs, and I showed you the syntax of that. So now the question asks, what is the default type of ports of an entity? The default types of ports of an entity are signals. Since ports of an entity, as you saw, ports of an entity, like it represents input and output of the circuit. Therefore, VHDL takes ports of an entity signal. So if you don't specify their type in the ports, it assumes that they are inputs are outputs and inputs are outputs are signals. So the default type of ports of an entity are signals. Option C. Now, another theoretical question. It states that microprocessor contains A. ALU, memory and input output. B. ALU, control circuits and register circuits. C. CPU, memory and input output. D. CPU, input output only. So the correct answer to this is our microprocessor. If I say microprocessor, it consists of ALU, it consists of control circuits, and it consists of register circuits. We will be discussing a microprocessor in details in week 11 and week 12 tutorial. This was just to give the brief idea about it. We will be mostly dealing with the questions related to microprocessor 8085 in next two tutorials. So for this, the correct answer is option P, ALU, control circuits and register circuits. So if there are doubts so far, please type it in the chat box. So Nitesh is asking, please share the YouTube link of past classes. Nitesh, I think they are available on this website, SOAM portal. If you can carefully look at, they have shared this Google Drive folder which contains YouTube links to all the live sessions, and it also contains the folder which has presentations also. Yeah. Assignment session, you are saying in SOAM portal on week 9 tutorial link is not available. Let me we can check it later after we solve this problem. We can just check it in this session only. I'll just check it. Otherwise I will just put it here only. I'll just check it once again. I have forwarded it to them, and actually we have just put it in the Google Drive folder. It will be always available. I'll just cross check it. So can anyone confirm, is it for all that week 9 tutorial link is not available? Okay, we'll just check it later without a question. We'll check it later. So we just saw this question. Microprocessor contains arithmetic logic unit, control circuits, and shift registers. Now we have this question. This is a snippet of a VHDL code, not a complete VHDL code, just a snippet of VHDL code. So it states that VHDL code, the code is given below. Sum is assigned to A XOR B, and carry is assigned to A and B. So first of all, I've just pointed out here that the sum here, it will be an output. Carry, it will also be an output. So and then we have this statement less than or equal to, less than or equal to. So this thing means assignment. This thing means assignment. So sum gets assigned to A XOR B, and carry gets assigned A and B. So if you remember from your combinational logic circuits that sum and sum, so we can discard, first of all we can discard full adder, because full adder has three inputs and two outputs. We can just discard this option right away. So we know this from our background in this combinational circuits. We have A and we have another input B. It goes to an XOR gate, and it's known as sum. And one and A and B once passed through AND gate gives the carry. So this thing, if you remember, this is an half adder. So if you can draw a truth table of that here, A, this is B, This is sum. I'll just write S only here. You can assume sum, and C for carry. So this is 0 0 0 1 1 0 and 1 1. So when 0 is at with 0, we have the answer 0 and carry is 0. When 0 is at with 1, we have the sum 1 and carry 0. When 1 is at with 0, we have sum 1 and carry 0. And when 1 is at with 1, we have sum equal to 2, which is 1 0. So it is sum is 0 and carry is 1. So this thing is represented by AND gate, and this is represented by XOR gate. And the snippet of VHDL code having this thing is simply an half adder. So yeah, I don't think there won't be any doubts regarding this, but still, if there are any doubts, you can type in chat box. I see some of the students have already typed the answer. That's good. So we can move forward to question number 9. So the question number 9 of today's session is: in VHDL, assert statement is used for A. Declaring flip-flops, B. Reporting warnings and error messages during simulation of model, C. Synthesis of VHDL code, and 4. Option 4. Place and route of design. So this is another theoretical question. You must know that this assert statement is used to print messages at the simulation console. So this assert statement is used to print messages at simulation console when specified runtime conditions are met. So this assert keyword defines one of 4 security levels. So this assert keyword defines one of 4 security levels. Number 1 is note. Note is when some conditions are information about it relays information to user about some condition. It relays information to user about conditions. Sorry for my handwriting. Then option 2 is warning. So it relays information about conditions. So it relays information about condition that are not expected, but are not harmful also. That are not expected, but are not harmful, or we can say in technical terms, that are not fatal. Then also it has this note warning. Then we have error. It relays information about conditions it relays information about conditions which will make our model, which will cause our model to work incorrectly. So because of this, model will work incorrectly. And then we have this final statement, which is failure. It relays information about conditions that are catastrophic. So among the following statements, the correct statement that gives the assert statement. So among the following options that correctly describes this assert statement is reporting warnings and error messages during simulation of model. This is the simplest thing. So in short, you can just say this is used to print messages at the simulation console when specified time conditions are met. So this is just another theoretical question. Now another question we have here is how many types of shift operators are there in VHDL? This is a theoretical question. So the correct answer to this is there are six type of shift operators in VHDL. So these are rotate, rotate left logic, rotate left logic, rotate right logic. So these are in short written as ROL, ROR. You can look up to, if you want more details about that, you can look to your tutorials and the reference book. Also we have this shift logic left, then we have shift logic right. Actually, it is shift left logic and shift right logic, so it is SRI. So it's here right. This there is logic. Let me just write it here. We have rotate left logic, rotate right logic, shift left logic, shift right logic, shift left arithmetic, shift right arithmetic. So this thing is abbreviated as ROM, ROR, SLL, SRL, SRE, SLA, and this right here is SRE. So the answer to this question here is 6. So moving forward to the next question. APAC. Oh, okay. Yeah. Yeah, you can just refer to your lecture notes. I will just there you can't find any. Yeah, you check it. So next question is it's related to the syntax of VHDL. So it states that a package in VHDL consists of commonly used architectures, commonly used tools, commonly used data types and subroutines, and commonly used syntax and variables. So a package in VHDL basically consists of commonly used data types and subroutines. So these are basically packages basically used so that the programmers can use them in their design without defining the same functions again and again. So just to reduce our to increase our efficiency and to reduce the work time. So these packages are already present in there. We can call them and use them in our design. Otherwise, we would have to just repeat them again and again. So without repeating them again and again, we can use them in our design. So a package in VHDL consists of commonly used data types and subroutines. So in VHDL, a bus is a type of A signal, B constant, C variable, D driver. So another theoretical question, in VHDL, a bus is a type of signal. It may have its driver turned off. Now I'll just before proceeding to some other questions, let me just check if there are any doubts. So I can see there are no doubts. Actually, this week session is mostly a bit theoretical, but I tried to include some coding portion also. I'll just discuss some basics of VHDL, some basic codes. So we'll just discuss them. So now here I'm going to discuss you with this and get in VHDL. So first, what we have here is we have this library. So we call this library IEEE. So the library is IEEE, and we use the package. So right now we just saw one package. So we use this package IEEE.stlogic1164.all. So this is the package we are using from IEEE. IEEE is the library and std underscore logic underscore 1164 is the package. So before we proceed to this entity and architecture portion, I have here some words that are in bold. I have this library, I have this use, entity, port, is, and they are in bold. So the reason why they are in bold, they are the keywords of this VHDL. programming. So like once I write entity, so this program knows that I am using this entity. I'm just calling this entity. So before we proceed, so here I am defining my entity for AND gate, where as I just told you earlier, we will just define here this input and output. So here I'm calling this entity. Then I have this AND gate. AND gate is a user defined name. So I have written this here is this AND gate. So then I write is and then port. And now I have port. I have my I am here simulating a two input AND gate. So I have two inputs. I have this input A and I have my input B. Then followed by the colon, and then I have my port direction. So these are my inputs. IN and IN specifies inputs. And then this std underscore logic, which means that it is the signal, 1-bit signal, followed by the semicolons. Now I also have the output signal Y, and this direction is specified by this keyword out, and then I have this std underscore logic, and then the parentheses are closed and followed by semicolon. So it should be here semicolon. And this entity is terminated by this keyword and followed by the entity name. So as you saw, we had this entity name and gate. I think this is case sensitive. Yes, it's case sensitive, so it should be same. Like we defined it here, it should be here also. Then we have this architecture followed by the architecture name. So and logic is my user defined name, and logic followed by the keyword of, and then and logic is my architecture name followed by of keyword of architecture. Then we have this AND gate here, this AND gate entity name. So here it should be entity name AND gate, and we have this is. Then we have this begin. So this begins, and then we have this Y assigned to A and B, for terminated by this semicolon, and this architecture is terminated by this AND statement followed by the architecture name. Here is AND logic followed by semicolon. You should not forget these things, semicolons and proper use of libraries and packages. So this was just to give them some brief idea how this we simulate this AND gate, and based on this I have constructed a small question here. Find the syntax mistakes in the following visual code of OR gate. Just you can say a like for like displacement, just to get an idea of where we are missing here. So here I have just included this library IEEE. Then I have written this use IEEE this thing. Then I have this entity. Then I have this architecture, and then I terminate the architecture. So we are just required to find some common mistakes we make in a hurry. So find the syntax mistakes here. So if you can see, library IEEE followed by semicolon is correct. Then I am using use IEEE.std underscore logic underscore 1164.al. So this thing is correct, but this thing is not terminated by a semicolon. So here we should have a semicolon, right? And then we have this entity OR gate, entity followed by entity name OR gate, correct? And then this is, and it's the port. Here we will define the inputs A, B, and Y. So A and B should be our inputs that are specified by this my port direction. So it's correct. And we have this std underscore logic specifying that there is a 1-bit signal. And then we have this output Y specified by this output direction and std underscore logic 1-bit output signal and terminated by a semicolon, correct? Here we have this AND OR gate. So if you can see here, again I have made a mistake here. It should be semicolon, not a colon, right? And this name should be same, which is same. Then we have AND architecture, architecture followed by architecture name. So here architecture name is OR underscore A, followed by of keyword, and then entity name, that's OR gate, correct, and then is. Then it should be begin, but begin is not here, so you'll just write the begin. And Y should be assigned as A, as the question asks us to write it for OR gate, A or B, but I have written as A and B, so it should be OR, and it should be terminated by a semicolon, this line, like this. And finally the architecture should be terminated by AND statement, END, followed by the architecture name. But here I have written this entity name, so this is also incorrect. So it should be OR underscore a. So this was the syntax for the OR gate. I had made some mistakes, so we pointed out the mistakes and we corrected them. Now moving to the next question. Next question is, which of the following is correctly declared library for a VHDL code? So we are getting some option. We have this library name use package dot parts. Option B, library package name dot parts library. Option C, use library, and option D, library use. We saw it earlier how we define the library, how we correctly define a library. Library is defined in two lines. So two lines. In first line, library is called, and in second line, use statement is provided. So how use statement is provided? So here I am calling library, let's say A. So if I have to use a package of A, so I will use, then I will use library name, that is A dot package name, what I'm using, dot parts. So as per the given syntax, option D is correct. If you refer to the previous example, we have this library IEEE, so I'm using this library IEEE, and then in this IEEE I'm using this package std underscore logic underscore 1164, correct? And with the dot all statement, I'm specifying that I'll be using all parts of the section of that package. So this was just to give a brief idea about the syntax. Now I have here these two codes. One is for 4:1 mux VHDL code, and another is for D flip flop VHDL code. So let me just go by the point by point. Here we are using calling this library IEEE, and we are just using all the other packages. So I will not go into the details of the packages and libraries. We just need to understand the working of the code. Then I have this entity. I'm just having this entity which I have named as dpen dpun underscore mux underscore out, and followed by the keyword is. And then we have this port. So here I am defining this input 1 as input std underscore logic mux input 1. So this here, don't confuse with this. This is comment line. These are comments. So this is the one advice I will be giving you. Whenever you are writing any code, whether it will be in any language, be it a hardware description language or Python or MATLAB, try to use comments. It's really helpful. So just out of my own experience, I try to use comments. This is a relatively simple code, but still try using comments in your codes. So this is port. Again, let me just start again. This is port. I'm using this input 1. This is the input std underscore logic. So this input specifies the input std underscore logic 1 bit signal. Input 2 again an input and 1 bit signal. Input 3 again a 1 bit input and 1 bit signal. Input 4 is the input name. These are the input names. So is input underscore std logic again a 1 bit signal. So we know that 4:1 mux has 4 inputs. 1, 2, 3, 4. These 1, 2, 3, 4, consider them as IN1, IN2, IN3, and 4. And we have these two select lines, and we have this one output. Output here is data out, that is ID. Then we have this select line. So there are two select lines for 4:1 mux. So it's written as this also input to the mux. So that's why direction is specified as input, and it's std underscore logic vector. So it's an vector, it's an array. And 1 down to 0 specifies that this is the MSB and this is the LSB. If it would have been 0 to 1, this would have been, so 1 down to 0 means 1th bit is MSB and 0th bit is LSB. So if this is like 1 0, this is my LSB and this is my MSB. 1 down to 0 specifies that thing. And this here is the comment of selection line. And finally we have this data out, which is the output D std underscore logic, which is the 1-bit signal. And finally we terminate this entity by using this deep and writing the entity name deepin mux underscore out followed by the semicolon. Now we have this architecture followed by the architecture name and followed by of, this is the keyword of this entity name, and then followed by is, and we have this begin. This is the syntax as we saw earlier. Then we are using this process statement. This process is basically in which code is executed sequentially. It consists of 3 parts. One is sensitivity list, which are represented in the parenthesis, which means to which the process is sensitive to. Any of the changes in this, the process is sensitive to this thing. And then we have the declaration part, and then we have the sequential part. So in whatever we write in the process occurs sequentially. So we start the process statement, and this process statement is started by this begin, and then we have this case statement. Case. So case when. So we are what we are here taking in case is the select line. So we are taking the select line inputs as case. So when select line. So when it writes when 00, it means case when select line is 00. So case when 00, when select line is 00, my data out will be simply equal to input 1. This one. When k is equal to when k is equal to 01 means when select line is 01, my data out will be equal to is assigned input 2. That's what mux does. You have already gone through mux. So basically when 00 is here, this bit gets selected, 00 is here, this input get, 1 is here, this one gets selected, 10 is here, this one gets selected, and 11 is here, this gets selected. This thing essentially does that operation. And when 1 0 input 3 gets selected and 1 1 input 4 gets selected, when other data out is 0, is then when none of these is the case, so my output is 0. So then we terminate the x statement, sorry, case statement by using this AND case followed by semicolon. Then we end this process statement by using AND process under semicolon, and then we end this architecture by using AND followed by the architecture name and the semicolon. So this was just the idea of the VHDL code of 4:1 mux. Now I also have this. There is some. Let me just check. Someone has just typed in. Yeah, Lalijit Rishi just type in. So if you are not able to type your doubts, you can just ask using your mic. Yeah, I'm all ears. Lalijit Rishi, are you there? Yeah, I think there must have been some mistake. So we can just move forward to the last part of today's lecture, which is this D flip-flop VHDL code. I thought I'll just give some brief idea about this also. So these are again the libraries and packages that we are using. Then we have this entity which we have named red. So we know that D flip-flop, we have this input D, and this is output Q, and we have this clock here. So here I'm writing this entity DFF1. So my entity name is DFF1, and then followed by the keyword is, and then followed by another keyword port. And inside the port, I'm just writing on my input and output signals and with their along with their directions. So this is another way of writing multiple inputs together. Rather than going in the line by line, you can just write multiple inputs. Like in previous examples, we had this input 1, input 2, input 3. We could have just write them in1, in2, and comma 3, then followed by the colon, then in, which means that all of these are inputs, single bit inputs. Then I have this output q, which is also a single bit signal output, and then I am ending my entity by using a and d dff1 terminated by the semicolon. So this is clear. Now we have this architecture followed by the architectural name, and then off keyword, and then entity name, which is dff1, and followed by is, correct. And now I'm using this begin statement. So here my process, I am in the sensitivity list, I'm using this clock, because you know this, I'm using this edge triggered flip flop, and this edge triggered flip flop is sensitive with my clock. So I'm using this clock as my in the sensitive list, followed by this begin. So I'm just here, I'll just ask, so begin followed by this if reset equal to 1, sorry, if reset equal to 1. So whenever this reset signal will be equal to 1, so my q will be assigned this value 0. This was pretty much straightforward. So when we reset the flip flop, we assign the value 0. Now this thing is interesting. This is our main part of the code. So I'll just ask one question here. Else if, so another condition is there, else if clock event and clock equal to 1. Can anyone just tell me what is this basically? Clock underscore event and clock equal to 1. Anyone can tell me what is this? So this thing which I have highlighted, if else if clock underscore event. So event, maybe some of you might not be knowing. So event is basically any change in the inputs, this thing will be executed. So if there is a change in the clock, so since we are using clock in the sensitivity list, if there is change in the clock, it will be executed. So any change, any event is basically any change in the signal. So if there is any change in the signal, this thing will be executed. So but it's having if condition, else if event and. So can anyone tell me what is this clock event and clock equal to 1? Okay, let me just tell this thing basically rising edge, correct. This is basically rising edge. So this clock underscore event means whenever clock is changing, but we are only having a change in the my flip flop. My output changes only when it's rising edge because I'm here using a rising edge. So how we will specify a rising edge? So see, clock changes here, and clock also changes here. Clock changes here, and clock also changes here. But when clock changes and it reaches to one value, that's my positive edge trigger. So this is my positive edge trigger clock. So when this thing occurs, my output will be equal to my input. That's what D flip flop does. So then I my and my and if statement, followed by the semicolon. Then and my process followed by semicolon, and then I end my architecture by using my and architectural name followed by semicolon. So this was just a brief idea about how we simulate these flip-flops, mux, and logic gates in VHDL tool. You can refer to your textbooks on any references for more details. I just wanted to give you some brief idea about this. So that was all for today's lecture, live session. So in case of any doubts and queries, please type them in the chat box. Yeah, 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 yeah. I know that. So I'll just check it once. So I have to log into Swayam. So problem solving session. Is my screen visible or not? Yeah, it's there. I'll just present. Stop presenting. I'll just present. You just this. Are you able to see my screen? So this is your this portal. So here you click on this problem solving session, and you get this. So once you click on this, here week 9 is there. This one is another TA from IIT Gandhinagar. So actually he's having his live sessions on Tuesdays. I have my live sessions on Sundays. That's why I think there was a confusion. So this is the link. If you can just check it. Yeah, 25th September. So that was all for today's session. I hope some of the concepts were clear. This was just basically this coding one. In the next two lectures, next two live sessions, we'll be discussing microprocessors 8085. Okay, thank you guys for joining.